totally forgot to start up Monster Cat. Oh, oh, perfect. Oh man, I totally misspelled. Yeah. Okay. Okay. So what I'm gonna do today is let's see, get status. Yeah, we're gonna get at. So today we're going to go ahead and start thinking about doing branch management, which is something I haven't done yet. Notice that I have committed everything to master at this point. Now, admittedly, I'm a one-man project, and Git branch management is probably one of those things that's very likely overkill for a project of this size and this early in the development stage. But it's always good to get into the habit of doing it right the first, even if it involves a little bit of extra overhead. So what I do here is, let's see if I remember the commands correctly. I probably have to reference just to see if that I got them correctly. Is oh, I almost forgot. Almost forgot. And all right. Let's put a little divider here in chat on Twitch, so I know if there's any new messages. So the refactor is complete. I am now doing having things in individual collections now instead of trying to embed documents deeply. Found out the hard way that MongoDB is not really friendly towards the concept of documents that are, for lack of a better term, that are deeply structured. He'll let you do it, but trying to do queries on those things turned out to be next to impossible. And in fact, Mongoose, which is the preferred database ORM for Node.js and Express, kind of borks on trying to search for documents that are more than 2 levels deep. Actually, I think 2 levels deep or higher is what it is, which kind of was a disappointment. My first experience with NoSQL was actually with XML databases, XML document store databases, and XML doesn't care how deep you embed your nodes and that kind of thing. You can search for them just fine. XPath is a very powerful tool. Um, Mongo does not provide similar functionality. Mongo still has a little bit of SQL baggage with it, despite it being a NoSQL database. In that, when you have documents embedded in documents embedded in documents, you do it the old-fashioned SQL way, which is to say, in your child documents, you put a reference to the parent document, the object ID, obviously. And I was kind of disappointed to hear that because, Mongo, from what I can tell, doesn't even support joins. So it's like, well, what's the point then? Well, Mongo's fast, so I guess it really doesn't matter that much. But had I known that, I probably would have went with MySQL for ahead of if I had known that ahead of time, I probably would have gone for MySQL. Another reason I picked Mongo is because I was kind of intrigued by the idea that since Mongo is like a JavaScript driven engine, that I could develop stored procedures in Mongo. But they strongly recommend not doing that. Application logic plus MongoDB is bad, apparently. Which I get because, store procedures aren't necessarily uh, protected by version control unless you have, like, fixtures and all that ahead of time. So I guess it's more difficult to maintain that sort of thing. Also, there might be other reasons for doing that as well too. It's just, yeah, kind of disappointed, but you know what? It is what it is. So, what I want to do is we're going to go ahead and create a develop branch here. So we got our master branch and everything is all nice and hunky-dory with our master branch. We're going to go do git checkout -b develop. Alright. Now we try to do a git push. I'm just going to come up with an error, and that's okay. And we've just created our new branch. And what I'm going to do next is start thinking about, yeah, we're going to create a sub branch off of develop. So we're going to go ahead, we are in the develop branch, so git status, we're in develop, git checkout, we're going to call it this because that's kind of the feature I'm working on. Then we want to do -b. Now we're going to get that error. That's okay. Boom. So what we've done is, if I were working in a professional development environment, working with other people and all of that, generally speaking, what I've done just now is kind of more or less what a lot of people do in those types of environments. You have your master branch, which contains stuff that sits on production. Anything sitting on your production environment should only contain things that are in your master branch. Um, you should not have any or hot fixes or anything along those lines on production. If there's something on production that isn't in version control, I want answers. And I have held people accountable for that sort of thing before, um, including a technical lead at one point in time. Nothing worse than holding your own boss to a mistake that they made. And they did it on purpose too. He should have known better. But anyway, that's neither here nor there. So, and then you have your development branch, which is actually not really the branch that you really do development on. Develop branch is just kind of like a coalescing point that developers, after they finish doing their separate branch, sub branches, they'll merge into the develop branch, and sometimes that's often the case where QA happens. Now, QA can happen before then too, so it depends on where you work and what kind of business environment you're in. But develop is it's not really a development branch. It's where work that is development is staged before it goes to the master branch, which in turn will be staged onto production. So develop is kind of like a central point from where development does happen, but you don't actually do actual commits in the development branch. You only do merges. All the actual development happens in sub branches off of develop. Work on new features or extensive bug fixes or something along those lines. Those happen in separate branches. Those separate branches are tested separately, and then when it's ready to merge them into the develop branch, you do so, and make sure that in the meantime you keep up to date with your merges. That's always important. And after you do your merges, you merge, or after you finish your thing and it's been properly tested, you merge into develop. Further testing occurs, and then it finally goes onto the master branch, which then is deployed onto the production server. So it's it's there. We have 3 branches now. Master, develop, and now there's pop birth, which is going to be population birth, which is a feature I'm working on presently. I'll be right back, folks. I'll be right back. Let's make sure I'm not on mute. I am not. That has been known to happen sometimes. So the thing that I'm working on right now is some logic to create new population. Because right now, let's go ahead and load this up really quick. Oh, it's still running. Interesting. So if I load this, okay. I've been running the aging algorithm quite a while. I haven't had a chance to program the die-off algorithm. So like the oldest person now is 110 years old. But one of the things I had been working on is aging the population, and that's successful now. But I don't have any new births. Now, the birthing algorithm is going to be a little bit more complicated than this. Right now, I'm just saying population size 10,000. That's going to be the number that I'm arbitrarily setting. And this is actually 10 units of 10,000 people, so it's literally 10 million people getting born. And I need to find a way of introducing new population into the regions that have existing population. And I got to be mindful of the regions that have existing population, because obviously if there's a region that doesn't have any population, people aren't going to be born there. People might migrate there. That's going to be a thing, but that's going to be a later development project. But people will not be born in a region that has zero population, obviously. So I got to find all the population, all the regions that have current population, so I can make the association. And then afterwards I will create the new population based on what types of populations are being tracked there. And right now the only one I have is human, but I'm going to write my code assuming that I have multiple types of populations, because eventually I will anyways. So people keep retweeting me. It'd be awesome if they also jumped on my channel. Yeah, at least this person looks like it's a real person. That's always nice. I get retweeted by a lot of bots. Yeah, you do the hashtag Node.js, and there's like 3 different bots that monitor that hashtag that they retweet to, which isn't the most horrible thing, I guess. But every time I start streaming, my phone just like starts going nuts, and it's like, especially since I'm expecting emails. When I hear my phone buzz, I want something that's relevant to me, not some bot. Alright. So let's see here. So I found out about this stream thing here, and I think I'm inclined to use it, because this method is going to be working with a huge amount of data. And based on my reading, using a stream means that, I'll probably incur less memory allocation by using it than if I were to do a find and load the whole damn data set into memory at once. It'll be a little bit slower because I'm, doing event handling and not just doing a straight up for loop, which YOLO. But I do like the fact that it has, 3 different handlers for dealing with the situation. Like, hey, this is like your thing that you're reading. Hey, here's an error that happened. Trying to read the thing that you're trying to read, and oh, this is the function that gets called when everything is all done. So it may not be as efficient as the other methods I've been using, but I kind of like it. I like the structure. I'm going to experiment with this. We're going to see how this works. I don't know if I'm going to use this particular paradigm with all the database methods that I use, but I think I'm going to use it with this one just because it's big. And if it works well for this, I'll go back and retrofit the previous invocations. Alright, let's go ahead and let's read in. So we got our population. So as this population starts growing, so we want to keep track of region and population type. Those are the 2 big things. So state data to keep track of population by region and type. Var oops. We'll just call it population tracker. Okay. So as this method gets called, it'll modify this variable up here. And when this is done, the close method will go ahead and do its thing. Which is going to be actually generate the extra population entries. Alright, so with the population, as is, what we want to do is we're going to gather data. So type and region ID are the two ones we care about right now. We're probably going to add to that later. Because we are going to our birth rate is actually going to be dependent on existing population size. We'll have factors in there like birth rate and other factors, because like, for example, like only a certain percentage of population is actually going to be capable of having babies. So this is not going to be like a constant number or anything like that. So I haven't really decided what kind of algorithm I'm going to use yet. I have an idea what kind of algorithm I want to use, but haven't really settled on it yet. So, and oh my god, I'm yawning. Gotta stop doing that. Yes. If population tracker has own property. I really hate that method name. I really do. Let's filter by region ID. Yeah, we have to do a region ID at first. Alright, if population tracker has own region ID, boom, boom. Yank, paste. Let's do our region ID equal. Since we're going, my rule of thumb is if I have to access a method or a object property more than once, I assign it to a variable. That's just a thing I do. Yank, paste. Now we have to also keep track of type. Okay. So population tracker has own property region ID. Population tracker region ID equals population type. And that should be the only thing we have to worry about there. Because on close is where the magic is going to happen, because that's the end of the loop. We're just populating an object at this point. So population tracker is going to be seeded with all this data. ID list equals object keys. For our index equals 0, len equals region ID list dot length, index less than len, index plus plus. All right. What that'll do is we can then go through and region ID equal region ID list index. I got a var in front of that. Space. And let's see. So this is where we're going to create our new guys. And let's do this right here. Var region population type equals population tracker region ID. Okay. So we got our two variables that we really care about. Population type, population tracker, yeah, that looks good. Never a good idea to really have a couple of beers before you actually start streaming. Oops, wrong one. Yep, population. So population type is this. Region ID is that. Okay. And then we save. Population save. I'm looking at this and I'm not seeing a problem. Oh, hey, yes. Let's error reporting. Ever mentioned that I really am horrible at typing? Not exiting, existing. Alright, so we got our debug messages. That's good. Let's try running the program. Oops, oh, wrong one. It's gonna bomb. Oh, really? Hmm. Well, it didn't report an error, which is good. Disappointing thing though is, yeah, no new data is being generated, or is it? Just drop the databases so we can start afresh. Yeah, I'll restart. Let's dump some data here. Oops, debug. JSON.stringify. Paste. Actually, we're going to want to do null 2. Let's give it a whirl. Empty. Why is it empty? Population tracker should, in fact, if population tracker has own property. that's not right. Population tracker, population tracker. Let's, double check, make sure things are spelled correctly. Alright. So... run again. So it is not getting called, but it was getting called previously. Why is population... What's going on with this guy? Oops. I think I need to JSON stringify that really quick. Alright. So, run it again. So it is actually not... What? Oh. I'm a moron. Boom. No errors either. That's pretty awesome. I should probably check for that sort of thing. Alright, restart. Boom. Okay. I keep forgetting. I clear the database. I have to reinitialize it. This means I just have to click a few buttons. Alright, now let's go ahead. Let's delete that really quick. Just declutter it a little bit. I know now that this will actually run, because it did run previously, but I want to make sure this runs. Oh, yes. So, population is not defined. What? What? Oh. So let's go back to here. What was passed? Oh. Pram.database.model. That is very correct. Boom. Take a few seconds. If this works, I'm going to celebrate with a beer. Unexpected token. Boom. Alright. Restart. Oh. Is this it? Oh, yay. Look at that. Solid population all the way down. I don't know why that ended up being 0. That's fine. I'm going to have some logic in place to deal with that situation. Yes. Alright, boom. Oh. Okay, that does make me happy. Be right back. back. And now that we have completed that feature, do we stop it? Yes. That's good. So, get status. And we are in branch pop burst, so let's go ahead and get add. Boom. Get commit. Get push. Alright. Now, here's the thing that we're going to do. I'm going to go to our develop branch. Alright, I'm going to do a pull. Obviously, there hasn't been any updates because I'm the only person working on this project. If I actually saw changes, I would have been concerned. Alright, so now we get merge, pop, birth. Bingo. Okay, then we push. Let's put those changes up to there. Okay, well, alright, that was weird, but okay, well, whatever. Now that develop is up to date. Now, I always have to look this up. Let's make sure. Refresh. Okay, looks like our code is in place. Get, delete, remote branch. Okay, so let's get branch dash D. So we're gonna go ahead and do that. And I believe it's just dash delete. Oops. Nope. Sweet. Alright. I have a phone interview. At 11 o'clock tomorrow. That's exciting. Now we're going to go ahead and create a branch called get top age. And it'll say, no, you need to set your upstream. And it conveniently tells you how to do that. I wish it were just a flag and get that would just say, yeah, really, I just meant to do that. Just do it. I don't care. Just do it. I don't know. So we created a new branch, and that's going to be the branch that we're going to work on. Well, I should have called it population death. But we're right back. So population, oops. I got population age, population birth. Or birth, because we're using as a verb in this particular case. But we're going to go as a population die. Die. Yeah, alright, so var population die equals function. Do we have... No, we didn't require any parameters of the ones above. What we're gonna do... compensation package from last job I applied to. I'm not sure if I'm going to get that or not. So the two variables that are two numbers that are extremely important in this particular equation that I'm going to be writing on screen here is negative 8.517 and 2.3026. And those are the two numbers. When you raise e to those values, you get 1 over 5,000 and 10 respectively. 1 over 5,000 is significant because in the United States, approximately when you are between the ages of 5 and 14, you have a 1 in 5,000 chance of not making it. That's just statistically. It has nothing to do with, various other factors. Well, I mean, it has everything to do with those factors, but, violence, disease, weird things happening. There's a 1 in 5,000 shot that you might not make it to your 15th birthday. And as morbid as that sounds, we're modeling a population here. And so we got to take that into account. So our baseline is 1 over 5,000. And to raise an exponent to a value, to get that value, is negative 8.517. So... literally a log of 1 over 5,000 is negative 8.517. And then 10 was just the value I ended up picking as high end, kind of arbitrarily. I might change that. But the upper bound for the logarithm of 10 is natural logarithm of 10 is going to be 2.3026. So those are the lower and the upper bounds of the exponential curve that I will be using to model the death rate. As population ages, each segment of the population gets that handy-dandy equation applied to them, and the population will erode as it gets older and older and older, and as it approaches the natural lifespan of the species, it will approach zero in a big hurry when it gets towards the end, which is what happens in real life. So I brought up the model before. I'm not going to do that now. I'm not even sure if anybody's even watching the stream right now, but hey. Do I even want to look at this? I don't think I want to look at this. That kind of scares the hell out of me. I love how celebrities these days are posting live videos to Facebook of them snuggling with their cats, which is kind of adorable, but it's really weird. Alright. So, the death rates between 1 and 80. Alright, between 0 and 80, we gotta normalize that between our lower bound and our upper bound. So what we're gonna do is we're gonna just set up some arbitrary variables. Lifespan equals 80. Boom. Now we'll even make it 80.0, just make sure we have this floating point. Minus 8.517 var x upper bound is equal to 2.3026. Over 5,000. Oops. And don't need parentheses there. ln 10. All right. Alright, so what I gotta do is the upper bound and the lower bound have a range. Normalize this to that range. And then get the exponent to that, and that will be our death rate. So, sort of. We gotta think about this really quick. Okay. This is kind of advanced mathematics here. Well, not really that advanced, but it's a thing. Okay. Okay. Field list. Okay. Actually, I just should do the die before the birth. Because birth is going to have its own algorithm for die off, aka the infant mortality rate. Alright, so, I don't think, yeah. For now, we just care about size. That was just me refreshing the page. I didn't actually. Alright, actually, I should check one thing here. No, no, don't. Why? Well, I'm the only person on Twitch right now. Alright, so if I'm just worried about the size, I'm going to apply the algorithm to that. And again, since we're dealing with large data, so we're going to opt for the stream. Alright, and oops. Do. Hey, no, don't do that. Thank you for not doing that. Alright. So, yes. I don't even know. I don't think I'll be doing anything on close. I'll keep that there. Population stream on this. Yeah, I think all the bulk of the stuff is going to happen on this layer because every time I go touch a population, there will be modifications done to the existing database entries. Age, I need age, that's right. Because the mortality rate is based on age. So, let's go ahead and declare the variables. Var population age is equal to... It seems silly to assign these variables, but I'm not doing it because it's convenient to type or not convenient to type. What it boils down to is that when I have to access an object key more than once or a function more than once or anything like that, I store it to a variable. It's good programming practice. I see a lot of people just call the same function over and over and over again to get the same damn value, and it's like, you know, programming languages are smart these days, but they're not that smart. You keep doing that and you're just going to drag the performance of your app down. So, I don't know, these parameters are going to be accessed quite a bit. So, age. Var exp range equals exp upper bound minus exp lower bound. And we're just going to do these calculations in the top level so that we're not doing it repeatedly for every data point that we find here. So, oops. Oh, alright. Var normalized age equals population age. Parentheses probably unnecessary, but we're going to do that anyways. Divided by lifespan. So that'll be a fraction between 0 and 1. Times exp range plus exp lower bound. So what that does is it takes the age, which is going to be anywhere between 0 and 80. Actually, it could be higher than that, but if it's higher than that, then the death rate is going to be higher than 100%, so everybody's going to die off anyway, so it doesn't matter. So 0 and 80, and it puts that into a fraction, and it finds a way to put that fraction between these two values. So that's what this method does. Population age divided by lifespan, yep, times explanation range, that gets it to these two values, and then adds it to this guy, which is effectively like subtracting pretty much. And then var mortality rate equals Is it math.exp? Let's double check. I will bet it is. JavaScript math.exp. Okay. Mortality rate? Yeah, let's get rid of that extra. Get rid of that typo. So normal age rate. Mortality rate is this thing raised to this power. Oh. Divided by 10. I don't even know what we call this variable. EXP divisor? We'll do it the proper way. I mean, this is going to be completely rewritten every which way with but Wednesday, but we're going to just do it that way. Alright. Or is it the dividend? I don't even care right now. Okay, so hold on a sec. JavaScript ln. Math.log. Oh, I am a moron. How will we do this? Math.log. 1 divided by 5,000. 0. Computers are good at math, so if you have to like have anything do math, let the computer do it. I'm pretty sure this is completely unnecessary. Alright, 1 divided by 5,000. Math.log 10. Might as well make that 0.0. So, because that's a floating point, I think that will take precedence. My C knowledge might be kind of compromising my judgment here, if that's alright. sound equals 1 divided by 5,000. Or how about we do this? Point 0.02. Okay. Yank, paste. I don't think calling these EXP. I think this is what we should call this log. 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 So I'm at the like upper bound, I'm at the lower bound. We'll kind of separate these out, have the constants separated from the equations. So log range, yank. Paste population divided by lifespan, yep. Log. Normalize H is that. Upper bound. Okay. Alright. Okay. Age, population age, death rate equals that. Death rate should more or less always be a number between 0 and 1, although it can be greater than 1, but never under 0. So, alright. Let's go ahead. I'm gonna spit out a ton. Yep. EXP upper bound versus EXP lower bound. Alright, yank, paste, yank, paste. Alright. I should think about fixing that bug. Boom. Look at that. Death rate 1 pretty much for age 80. I can't really expect anything else. And here, yeah. I can't really expect any better than this. Notice how the death rate remains pretty low right up until you hit your 60s, and then it starts skyrocketing. Which is kind of the thing that does happen. Alright, so now this is read-only mode, which means that I can't modify these things. So I gotta do an independent update. That's fine. Var adjusted age equals population. Nope, adjusted size. Math.floor. Maybe round. Nah, floor is fine. Let's do round. There is no round, is there? Wait a minute. Round to whole number. It is round. Alright. Okay. That's good. Looks like I'm probably going to need the ID. So adjust the size. Boom, boom, boom. So with the adjusted size, yeah, we'll just copy the whole thing. Conditions, ID, here's our population, ID equals population, ID. Yank. Yank. Paste. Now I gotta look up the update method here. Mongoose update. Alright. Query, yep, name. Alright, so yeah, it's that easy. Alright, sweet. And size, adjusted size. We are only not, we're not going to do multi equals true. So parameters, boom. I want to do one thing though. Let's do this. Nope, nope, we don't want to do that because we're going to end up with insanely huge negative numbers because of the exponential. So let's be a little bit careful. So if adjusted size is less than 0. Alright, mongoose. Delete. It is find dot remove. Okay. There's probably an error condition associated with it, but I'll worry about that in a sec. This is the part where it gets scary. Let's run the code. Nope. 90. Unexpected string. 89. Alright. 89. Go. Yeah, well, that would explain it. Oh. Oh. Okay. We will refresh the screen as soon as I remember to Start the web server. Restart. Log in. Oh, so close. So close. Oh, so this. Oh, did we run into a train wreck situation? I bet you we did. Yeah. Alright. Let's Control C out of that. Drop the database. Boom. Slow down. Edit. Bin Drexel. How about we do once every 20 seconds? Let's restart. Alright. Okay, why are these guys staying alive? They should be quite dead. Well, this is fine and all, but I don't want immortal zombies, geriatric zombies. These data points should be removed. So I will go ahead and cancel here as soon as this is done. Yeah. So yeah. I don't think this remove method is working so well. Drexel.js. Okay. If adjusted size is greater than 0. We'll be fine by ID. Alright. data population model, find by ID and remove. Maybe a better way of handling single handlers. It's still not finding it. Alright, debug. Let's just drop the database. Restart the app. Yeah, I got a lot of work to do to make the app a little bit more crash resilient. Okay, so far so good. Restart. Yes. So that is what we should be seeing. So why is it not deleting the entries? Yeah, these values are way below 0. So that means that this code is getting executed. Oh. Let's call back. I know what's going on. What is the callback? I know what a function is. I just want to know what the callback fallback is well, you know what? We're just gonna do it that way, and we're gonna get that out of there. Node crash. Unexpected token. Not sure. Oh yeah. Well, there's a. Oh, I know why. Alright, there we go. We're getting close, I can feel it. Oh, it's already ran. There we go. Oh, we got a little bit of a trail off here. That's pretty sweet. Wonder if I should probably make this a little teensy weensy bit. Nope, that's fine. I think over time this curve will settle down, so I'm just going to let it run for a little bit. I should probably have a little interval, just reloading this screen every now and then anyways. Yeah, it's starting to settle down a little bit. Now it will asymptotically approach a stable population. Okay. I could probably make this higher than 82. Realistically, it should probably be like something like 100 based on what this curve looks like. Because 70 to 80 is like the average life expectancy in the United States. So this curve will not nearly be that steep in this sort of situation. But ha 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 ha. I did it. I did it. I did it. Population simulator. Ooh, ooh. Yeah, it's starting to settle down to a stable curve. I'll be right back. I'm going to let this run for a little bit. Okay, so it looks like the curve is sloping down pretty good. Might have to. That's a pretty steep decline right there. I don't think the. Well, I mean, it's an arbitrary value, really. I kind of wanted to kind of match it with as closely as possible to post-industrial age United States. Oh, hey, what's going on there? All right, starting to settle down there. This makes me excited, so excited. Oh my god. It finally works. It actually, honest to God, works. Oh man. Curve is still settling down. And this is fairly consistent with what the mortality or the population graph looks like for, by age for the most part. I think this is a great thing. Now, I have multiple reasons for breaking out population by age, not just because I wanted to model a realistic population growth curve. Um, in addition to that, as the population ages, it'll bring certain memories and experiences with it. Take, for example, the Vietnam War, we'll just say. People who grew up during the Vietnam War remember the Vietnam War, and that's like the defining moment of their lives because that was a really serious thing at that time. And so, certain parts of these curves, if there's a significant action, like if the empire is at war with something, there's going to be a significant portion of the population that are going to remember, oh yeah, we were at war during this one time. And so, like, for a 10-year period, like people who were during the formative years at that period of time are going to have that imprinted on them. They're going to carry that with them, and that may make them more war loving or more peace loving as they move forward. And while their productivity or while their birth rate might decline as they get older, their influence will increase, and so that will influence population, just basic overall how the population views certain things around the world. And so as the population gets older, they get to this certain point, and there'll be echoes too, because like there'll be children who will be there'll be children of and grandchildren of people who have experienced certain things, and they'll have a certain level of affinity for their parents' political, socioeconomic views. And so that's going to be modeled in this game. That's going to be like, so as your empire goes to war, or they make economic decisions or something along those lines, it'll be reflected on the population's view of the universe around them on top of that. So, and yeah, that'll be a thing. Oh, that'll be a thing. Oh, will it be a thing? Yeah, so the population has settled down pretty good. Kind of curious as why that little wiggly thing happens. Seems a little unusual, but I will fix that because what will happen as the universe updates, so you literally like each universe will have a shadow copy. So after the game is done updating the universe, it'll copy that universe over to the shadow copy. I'll flip over to the shadow copy, and then I'll proceed to update the universe on the other side of things. Oh, this makes me so happy. I have an actual curve, an actual graph. Oh, man. Just looking at it, it's so pretty. Those data points are being generated from an algorithm I developed. I developed it. Oh. Hells to the yes. Boom. Oh. I can't tell you, this is like really exciting to me. Just to see this in action, to actually see. Yeah, so the curve has settled down. I mean, just look at it. It's just like the curve goes down like this, and then it kind of settles off and it trails off to the end. And that is exactly, this is exactly how human population models work. It's it's textbook. This is literally like research population census data, death rates, birth rates. I made this is what I made happen based on my research. Oh, I wish I was like applying for a PhD right now, but this is actually, man, this is not that complex of a model. but nonetheless, oh, boom. Oh, I'm excited. We are going to commit the hell out of this code. Alright. Control C. Control C. Get status. Yeah, get add. Get commit -m. Rudimentary. Model framework in place. All right. Based on this data I'm generating, I'm gonna have to like start generating more advanced. Yeah, I'm gonna have to generate more advanced data, such as average, or or mean life expectancy, average life expectancy, that sort of thing. That's gonna be a thing I have to deal with. I'll be right back. I'm just like so excited. I am back. Alright, well, I think it's fair to say that this is a good spot to kind of end the stream. I'm really happy with where this is at. This curve is something I was trying to achieve over the past week, or something like it. I don't know how I could have achieved a better result. This is great. Now, of course, there's more work to do. The population model assumes a constant birth rate, which is completely unrealistic. Populations grow and wane based on various, various parameters and all that. So, and that algorithm will get more complex over time as I develop the game. Of course, I shut down the web server, so it's going to be like, nope, 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 nope. So, yes! This whole algorithm takes, well, it took longer than 5 seconds. I did notice it ran into that problem. But I'm okay with it. I'm actually kind of expecting that each iteration might take up to 20 minutes. Might even be longer than that. I'm anticipating the fact that some universes will be so large that each iteration might take an hour. We'll have to see if that's going to be a thing. But folks, I appreciate you watching, and I'm glad you joined up. If you did, I'm gonna go hang up the streaming thread right now. Refresh the screen really quick, see how many people viewed the stream. Yeah, not too bad, not too shabby. Alrighty, well, I'm gonna go ahead and exit. I bid you adieu, and you have yourself a great